Okay, so today I'm going to talk about application of machine learning or artificial intelligence in the call center environment. It's going to be a very high-level discussion, so if you were hoping for a deep dive into linear algebra, you're not going to get it today, sorry. Yeah, so this is specific to call center. The use case that I'm going to be discussing today is not necessarily related to marketing, but there's a lot of other aspects of marketing where you can apply machine learning. So this basically we'll be discussing a case study. And the case study is something that I worked on for about a month for a real call center. So we built a solution for the call center. It was basically a month of work between my group. It was just me and one other person. So I'm just trying to point out that this kind of work is not necessarily very time consuming or very difficult. So it can be done in a relatively short amount of time. So before I get into the use case, I just want to cover some of the definitions on what do we mean by artificial intelligence and machine learning. So here's a pretty good definition that I found of AI and ML. So ML for machine learning, and I think there's confusion between what's AI, what's ML. So AI, I'll just read that out. AI is the ability of a machine to perform cognitive functions we associate with human minds. So things that humans can do naturally and are pretty good at doing it. This is a way of software to replicate that. And what is machine learning? Machine learning algorithms detect patterns and learn how to make predictions and recommendations by processing data rather than by receiving explicit programming instructions. So in the past, we would write code and we would be like very explicitly writing code to solve certain problems. In this case with machine learning, we don't actually write the algorithm that solves the problem. So the machine is literally like learning these algorithms on its own. So for the rest of this presentation, I'll be focusing on machine learning, not AI. So AI, you can think of machine learning as a subfield of AI. So AI is really vast. So from self-driving cars to a lot of image recognition, all of that falls under AI. Machine learning is more relevant to us because it solves a lot of the business problems that we face day to day. So more detail on machine learning. Machine learning, so it's the models are probabilistic. They're not like guaranteed answers. So if I say, so here's an example that we can look at. Let's say we have on a graph a bunch of collectors, and the collectors can be segmented into engaged versus disengaged collectors. Now, how do we draw a line through that graph to find out which are the engaged collectors and which are the disengaged collectors? So machine learning can solve this problem, and it will basically give you an algorithm that will plot out that graph. Now, as you can see, the graph is not perfect. There's a engaged collector which falls in the disengaged collectors list. So this is just showing that it's probabilistic. It's not like 100% accurate. It can tell you that it's accurate to like 98% or 95%, but it's not 100%. So how do we improve that accuracy? There's basically two main ways of improving the algorithm. One is more data. So the more data that you have, the more fine-tuned the algorithm will be and the more accurate it will be. And the second way is to try different types of machine learning algorithms. So I've listed some there, so, linear regression, decision trees, neural networks. These are all different types of machine learning algorithms that we can try. Okay, so the question is, why is AI taking off in the last couple of years? And even though some of these algorithms and techniques have been around for over 30 years, so why is it happening now? And one of the reasons is computing power. So computers are getting faster and faster. There's something called Moore's law. So Moore basically proposed that the semiconductors in a computer, the computer chip basically is doubling in power every year. So when you see that plotted graph, if that's showing the power of computers, it's increasing, it's doubling every year. So it's basically an exponential curve. It's growing at a very rapid pace. And some people predict that in the next 50 years, that graph will almost be vertical. And that's the point where people get scared about Terminators and other AI taking over the world. So maybe another 50 years. We don't have to worry about it now. What's another reason why AI is taking off? it's the amount of data that we have accessible to us. So this is a fun fact that I found. Just read it. So more data has been created in the past 2 years than in the entire previous history of the human race. So that's quite a lot of data. And finally, the other reason is the invention of these algorithms. So neural networks, it's been around for a while, but it was like we didn't have the computing power or the data to support the neural networks. So what is a neural network? It's basically taking the idea of the human brain and replicating it in software. So you can see in the diagram there, there's the biological neuron. That's one of the pieces of our brain, how our brain works. So what computer scientists and neuroscientists have done is use that knowledge of how the brain works and created a software model of it. So the software model is called a perceptron, and that is how basically a neural network works. And it became more popular in 1986 when a guy called Geoffrey Hinton, he proposed a way to use it to solve a lot of problems. So in 1986, actually it didn't get popular then. He proposed a solution then, but at that time, computing hasn't caught up yet to like really make it worthwhile. But in 2012, he used his algorithm to win a contest, basically. It was like a contest where you detect images. So he was able to win that contest, and he showed that these algorithms work. So in some ways, he's considered the godfather of AI because he kind of brought it to the forefront. And the cool thing is he's a professor at the University of Toronto. He works for Google now, but Toronto has played a really large part in North America or the world even to bring AI to the world. Okay, so now we're going to dive into the case study. So this is what I mentioned earlier, the project that I worked on, and we actually had the project, we had a problem that was explained to us, and we had to find a solution for it. So we looked at different machine learning techniques, we implemented it, and we deployed it to the production pipeline. So we'll go through that. So what was the problem? So this is, again, a call center that deals with like help desk tickets. They get service tickets, and they have to respond to service tickets. An example here, these are the kind of tickets that they receive in their queue. So they may get an email that says, my computer is not working, or my printer is out of ink. So their challenge is, how can they automatically place these into the right queues? So if they were able to direct, for example, the printer problems to the hardware department, or the software problems to the software department, that would save them time. So how can they do that automatically? So again, here we have divided up the tickets into different categories. That's our challenge. That's what we want to accomplish through machine learning. And this, in our own company, like we have calls coming in through IVR with like different categories. So it's something that maybe we could even apply to voice channels as well. In this specific case, it was emails. Okay, so to solve this problem, we use something called CRISP-DM. It's a methodology that's popular. That's one of the most popular methodologies in the machine learning world. So what it stands for, Cross-Industry Standard Process for Data Mining. And it's basically, you can think of it like an agile methodology. It's an iterative process of building the model and fine-tuning the model until you have a model that's very accurate. So I used this CRISP-DM technique, and it's basically, those are we're going to go through the 4 steps. So the first step is the business understanding. This is where you lay out the problem that you're trying to solve, and why you're trying to solve it. So in this case, because if we can categorize the service tickets, it reduces the amount of time it takes to handle a service ticket. We can also identify where the problem areas are. If we are able to categorize them and we see that a lot of the issues are printer related, then maybe something is wrong with the printing setup in that company, and that needs to be addressed so that we don't get so many tickets for printing. So those are some of the reasons of why we want to do this. The next step is to look at the data. So this actually, in the CRISP-DM, in this type of methodology, the data preparation is what takes the most amount of time, because the data that we often get is very raw and unformatted. So in this case, it's in the form of logs. So this takes a lot of time to tweak the data so that the machine learning models can do something valuable with the data. So what we did was, in the first step, we did data cleaning, and basically taking the data and putting it into a nicer form. So as you can see here, my cursor is not there. Okay, so in the blue box, you can see that we've taken the raw data and formatted it into just a column labeled data where you can see the text in each row. Once we have the data in a nice format, we do what's called EDA, or exploratory data analysis. So we basically try to look at the data and manually try to find some meaning from the data before we dive into modeling. In this case, I looked at ticket resolution time. So how long does it take to process different types of tickets? The bars are color coded, so you can see that. Oh no, sorry. So those it's just showing the amount of time it takes. So on the left-hand side, those are quick. So the blue tickets are handled at a fast pace, and the pink ticket takes a long time. And then we also looked at the ticket types. So this is where you can identify right away that software issues, which is the bar in blue, is like the majority of the issues. There's a lot of also issues dealing with email and user accounts. There's not so many issues with, that's a little difficult to read, with firewall, for example. There's like right at the end. There's not too many issues like that. So these graphs can help you set some metrics. When we implement the solution, we can look at these graphs again and see if performance has improved. So this is a way of telling whether the work that we've done is valuable or not. Now, moving on to modeling. So this is the main machine learning stage. And here, we actually do two steps in modeling. So I'm going to talk about the first stage of modeling, where we do something called an unsupervised learning algorithm. So this is where, as you saw here, when we formatted the data, we basically have the text, and we have no labels for the text. So how machine learning algorithms work, they need to be able to look at data that has been labeled. So to learn, for the machine learning algorithm to learn, I have to tell it that I need help installing is a software issue. So without knowing that, then it has no idea. So again, another thing I mentioned was that the accuracy is dependent on the amount of data. So the more data that we train the algorithm on, the better it'll be. So back to topic modeling. So what we do here is we try to find a model that will divide up the service tickets into the proper categories. So there are many models that are available to us. So for example, there's these, I'm not going to get into the detailed implementation of any of these models, but there's LSI, NFF, and LDA are techniques of doing topic modeling. They take data and then they bucket it into different topics. So what we did, again, because it's an iterative process, we tried all of them and we found that the best one was LSI. And this graph kind of tells you why it's good. So the coherence score shows how good it is at separating the topics. And the number of topics where it has the best coherence score is about 4. So what that graph is saying is that it's able to categorize the service tickets into 4 topics pretty well. But if you say divide the category into 10 topics, then it's not so accurate. And again, we can see an example. So what the algorithm has done is it's created this table here, and it's called the columns topic 1, 2, 3, and it's bucketed the tickets into these topics. Now, it doesn't know what those topics mean. We have to look at it and then label the topic manually. So if I look at this and I see topic 1 looks like it has to do with software issues. Topic 2 looks like it's printer issues, and topic 3 is like a facilities issue. So we have to go in there and look ourselves and see what the algorithm has decided, but the algorithm doesn't know these different topics. So once we've done that, we basically have data that's bucketed into topics, and we can move on to the next phase of the modeling. The next phase, so the winner was LSI. The winner was LSI. So what we do, I'm just going to walk you guys through the pipeline here. So the blue new tickets, these are the tickets that we feed into this database, which is the yellow database contains all the tickets that are unlabeled. We feed those tickets into the LSI model, which I just discussed in the previous slide. And it creates a new database of labeled data. So now we have in this green database tickets that have labels. So what we can do now is start training our neural network model. So in this red box, what we tried was something called CNN network. So it's called, it stands for convolutional neural network. It's a type of architecture. It's very popular for like image detection. So anytime you're using a camera and it detects a face, it's most likely using a CNN. And we also tried other networks. So we tried something called long short-term memory network, and short for LSTM. So LSTM networks are commonly used when you, in Google Home or Alexa, when you're trying to detect speech, that's when you use LSTM. So the long short-term memory part of it is because to understand the meaning of a sentence, you kind of have to know the context. So if you just look at one word and you know the definition of the word, that doesn't tell you the meaning of the sentence. So this algorithm takes into factor the...
I found these.
Oh,
The first
I don't know why it's listening to me. Yeah, it's taking over. Yeah, so yeah, long short-term memory is used for that purpose. Something I forgot to mention in the previous slide, when I said unsupervised learning algorithms, there's a very good example of that is your Gmail spam filter. The spam filter looks at emails that it's never seen and is somehow able to label it as spam or not spam. So it uses an unsupervised learning algorithm to do that. Okay, so we tried a few different algorithms, and then the graph on the right-hand side, it shows the accuracy of the model. So basically comparing all the different models, we found that CNN was the best one that, that we finally settled with. So CNN is our final model. Then our goal is to deploy the model. So now that we've developed the model, we want to give it to the software engineering team to put the model into practice. So what we do is we create an API out of the model. So what this means that software engineers can use the API. They don't need to know anything about machine learning or data science, or they don't have to be machine learning engineers. They just use the API. So in this scenario here, you see the API is implemented in that diamond there, and it's able to take new tickets and place it into the proper queues. So that is basically what we were able to accomplish using machine learning in this use case. Any questions about this particular use case? Good. Okay. So moving on, I'm going to talk about some other use cases, and this is where I threw in some slides for our marketing friends. So another use of machine learning in this scenario, I'm just going to read the background here. So when I worked on this, so this was basically a project that we did at York University. They don't have any affiliation with Air Miles or anybody else, but this was the example they gave us. Our client is a chain of retail gas stations, and they would like to increase their sales of premium fuel as it is a higher margin item. So that's the background. And our client is part of a coalition loyalty program, example, Esso with Aeroplan or Shell with Air Miles. So I think this is a pretty typical scenario for us as well. You want to identify who to send emails to because you want to upsell or sell more premium fuel. Again, the marketing strategy here, you only have a budget where you can reach 20% of your customer base. So if you look at the pie chart over there, you have a large amount of collectors, but you can only spend on 20% of them. So how do you identify who are the best candidates to send the email to? So in a scenario like this, you often use what's called a lookalike model. So you find customers that behave in the way that you want, and you find similar customers to the ideal customers. So customers who've purchased premium fuel, can you find other customers who haven't purchased premium but who behave like those customers? So again, machine learning algorithm can be used to identify the good candidates for upselling or to introduce premium fuel to. Some other scenarios that we can use in marketing. So Segmentation and targeting, that's what we discussed in the previous scenario. You're trying to segment your collectors into different groups. Another way to use machine learning is recommendation engines. So in this case, you are a good example is something that Zero Gravity Labs has done for us. So they've looked at the checkout baskets of people shopping at Sobeys, and based on that, based on what a customer at Sobeys has purchased, they're able to infer what a similar customer will purchase in Metro. So you have no data from Metro, but you're able to kind of infer that because the customer behavior is similar. Okay, so I think that's about it. I actually thought this would be longer. I didn't practice it, so it wasn't an hour presentation. So it's good. We have more time if you guys have questions and stuff.